Okay, today we're going to be talking about basic probability and the fundamental counting principle. And just so you know, you're going to have a quiz, not tomorrow, but on Wednesday, on basic probability and fundamental counting principle. So, today we're going to be talking about chances. Life's choices are based on chance. A good example is insurance. You know that you're paying your car insurance every month. You pose the risk of paying for that, and you might not ever need it. You pay because there's a chance that you will need it. If you need it and you don't have it, that's not good. But if you have it and you don't need it, that's not good either. So life is about chance. Probability is the chance something will happen. The probability of the occurrence of event A is given by P of A, which means the probability of event A equals the number of favorable outcomes over the number of total possible outcomes. So, the total number of possible outcomes is called the sample space. So if we were to list the sample space of rolling two dice, two dice, that's how you pronounce it. Get some colors I like and make my pen skinny. All right. You put the sample space in a curly bracket, which didn't work out too well. All right, so you're rolling two dice. The first dice could land on a 1, and then the second one could land on a 1. Or the first dice could land on a 1 and then a 2, a 1 and then a 3, a 1 and then a 4, a 1 and then a 5, and a 1 and a 6. Or you could have a 2 and a 1, or a 2 and a 2, or a 2 and a 3, or a 2 and a 4, or a 2 and a 5, or a 2 and a 6. Or a 3 and a 1, a 3 and a 2, 3 and a 3, 3 and 4, 3 and 5, 3 and 6, 4 and 1, 4 and 2. This is the sample space of rolling two dice. And I will ask you to do this on a quiz, so make sure you know what I'm talking about. And lastly, so if you were to count those up, you would see that there are 36 possible outcomes. And then another curly bracket. All right, so let's talk about a deck of cards. Now, I'm not going to list all of my possibilities with deck cards because that would just be too much. But I do want to talk about things in a deck of cards. There's 52 in a deck. There's 13 of each suit. There is 4 suits. All right, and they range from ace to king. All right, so the branch of mathematics that studies different possibilities for the arrangement of objects is called combinatorics. One way to determine the possible combinations is to draw a tree diagram. You've probably done this before. So let's draw a tree diagram. If I am trying to pick, I'm getting dressed for school and I can either wear a red, blue, or white shirt, jeans or sweatpants, or tennis shoes or flip-flops. I need to draw a tree diagram. So I have these shirts, red, blue, or white. These are my shirt choices. Then I have pants choices. I could wear jeans or sweatpants. Jeans or sweatpants. Jeans or sweatpants. Then I can wear tennis shoes or flip-flops. Tennis shoes or flip-flops. Tennis shoes or flip-flops. And then you can count your total number of outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 possible outfits. All right, so that is a efficient way, well, not efficient, but that can help you find how many possible ways. But you agree that if the numbers are large, that would take a long time. So we say we work with the fundamental counting principle. That says, suppose one event can be chosen in P different ways, and another event can be chosen in Q different ways. Then the two events can be chosen P times Q ways. That's a multiplication symbol. So, suppose an ice cream store offers 3 types of cones and 31 flavors of ice cream. How many single scoop ice cream cones are possible to buy? Well, you can choose the ice cream 3 types of cones. And then there's 31 flavors. And 3 times 31 is 93. So there's 93 possible. Let's go back up to our clothes option. I had a choice between 3 shirts, 2 pants, and 2 shoes. 3 times 2 is 6. 6 times 2 is 12. And when you did your tree diagram, you got 12. All right, so in a certain state, car license plates display 3 letters followed by 4 numbers. How many license plates are possible if? First, repetition is allowed. So you have 3 letters. So 1, 2, 3. And then you have 4 numbers. 1, 2, 3, 4. How many license plates are possible if? All right, so in this first spot, you're picking from 3 letters. There's 26 letters to choose from. Times, you're allowed to repeat. Repetition is allowed, so there's 26 and 26. Why is there 26? Because there's 26 letters in the alphabet. Now we're on to the numbers. There are 4 numbers. You're choosing numbers between 0 and 9. If you were to count the numbers between 0 and 9, you got 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 numbers between 0 and 9. So you have 10 numbers to choose from. And these are being multiplied. I just wanted to space. So when you type these all in your calculator, 26 times 26 times 26 times 10 times 10 times 10 times 10, you get a very large number. All right, your large number is 175,760,000. Well, that makes sense, right? There's a lot of cars in each state, so there needs to be a lot of license plate options. Now we're going to do the same thing, only this time repetition is not allowed. So I have 3 letters and 4 numbers. All right, so for my first letter, I have 26 options because there's 26 letters in the alphabet. But repetition is not allowed, so whatever letter I used, I can't use it again, so now I only have 25 to choose from. And repetitions are not allowed, so I had 25, but now I only have 24. So I can't use these letters again. Now over here, repetitions not allowed, so I have 10 to choose from. And then I only have 9 because I used 1. And then I only have 8 because I used 2. And then I only have 7 because I've used 3. And you type this in your calculator. 26 times 25 times 24 times 10 times 9 times 8 times 7. And you get that number, which is 78,624,000. So that's smaller. Well, that makes sense because you're not allowed to use letters multiple times or numbers multiple times. So it makes sense that it would be smaller. All right, and that's all I have for you. Thank you.